Okay, our last transformation that we are going to look at is rotations, or our rotations. So rotations, I know I just said that reflections can be tricky. This one might be one of the trickiest. It's a little weird compared to our others. But what happens is kind of like where we have a line of reflection that we reflect over. When it comes to a rotation, we have a center of rotation. So we have a fixed point that we rotate it around. 99.9% of the time in this class, what we're going to see is going to be over the origin, which of course is 0, 0. So if we look at this little chart right here, I'm going to go ahead and let you know this is a very important chart to have written down somewhere, because this is the process of what happens when we rotate. So unlike when it gets reflected and stuff like that, it's going to get turned around. It's a little tougher to kind of map and come up with our stuff. So here's your angle of reflections. You're going to get either 90 degrees, 180, or 270. So of course each of those going up to 90, and then 360 would be back where it started. We have a pre-image, and then we have our rotated point. So this is where our prime is. So if you kind of look at these, those look a little different and a little weird. One thing that I want to emphasize, so we kind of see a few things here. With our x and y, like in the 90 and the 270, basically switch places, and then when we look at our 180, how all of those are negative, or how it's the same x and y, it's just negative. We do see a negative there, but I want to emphasize this with that. So this negative sign means, put spin, sign means opposite sign. So you're changing the sign, not making it negative. So if you have a negative number in that coordinate, when you see over here where it has a negative on it, basically what happens is you got two negatives, they cancel each other out, and you get a positive. Of course, if it's positive, it's going to become negative. But this does not mean that it is going to be negative. So please don't, that's like the number one mistake. So please don't make that mistake with these kind of problems. So let's look at example 7 and kind of see how this plays out. So of course, first we need to graph these correctly. So if we look, we have our figure over here. We see we have a quadrilateral. So we're more focused in on our coordinates. So let's take R right here. So R is 3, 1. If we read our problem carefully, it tells us that we have a 270 degree rotation. So that means I'm going to be focusing on this, and more importantly, that right there, our y, negative x, or just the easiest way to say it's negative x. So if I notice, my coordinates are going to flip. So I have a 3 in the x, I have a 1 in the y originally, so those are going to swap with one another. So when I look, my y swaps over, my sign is going to change with my y. So that y is going to stay the same, which is 1. Now when I look at my x, it has that negative in there, so that means I'm going to change the sign of it. So if that was originally a positive 3, this is going to be a negative 3. So my r prime is going to be 1, negative 3. So I start out at 3, 1. I have to switch those two around and then change the sign of the x, which is going to be the 3. When it comes to these, I think switching them around first is the easiest thing to do. So like, for example, when I look at s, so s is 5, 1. I'm going to go ahead and swap those, like in my mind, I'm going to go ahead and switch those. So I got 1, 5. And then my x I originally had, which was this 5, is going to become negative, which is going to be my negative 5 right there. 1 there, and that is going to be my new coordinate. Let's take a look at t. T is over here at 5, negative 3. So when I go and do that one, my 3 is going to be my y. That's not changing, so that's going to be a negative 3 there. And then my 5 is going to flip over. It's going to be a negative, changing that sign, so it's going to look like that. And then when I look at u, that is going to be t, negative 1. I'm sorry, 2, negative 1. So when I go and think about flipping those around, my x over here originally is going to end up becoming negative. Y, of course, stays the same, so I'm going to keep that negative 1 over there the same, and then flip that around to be a negative 2. So in this case, our y doesn't change. So if you look at your y's originally, that 1, 1, negative 3, negative 1, all of those stayed the same over there. Only thing that changed was our x's when we flip those over, and we see that right there. So let's go and graph these really quick and see what we get with our rotation. Okay, so right there in blue, of course, is going to be our new image. So like I said, I rotated this 270 degrees. This actually goes counterclockwise. So it went this way like that. And it should kind of make sense because if I went 90 degrees, that would be a fourth of the way. So 90 degrees would be like right in this area. If I did 180, 180 would be over here in this area, directly opposite from it. There's where my 270 would be. And then, of course, if I go all the way back, I'll be at my 360. So that's how we work these kind of problems. Like I said, they're a little tricky. They require probably a bit more practice and a bit more concentration and paying attention to compared to the other problems. Okay, so we have example 8. So this one tells us that our reflection is 180 degrees. So I want you to, actually we have two of them here. We have a composition by rotation. So we're going to do a rotation first, and then we're going to go and reflect it over the x-axis. So this one I want you to try on your own. We'll take it kind of like one step at a time because we got two different transformations going on. We have a rotation and a reflection. So of course graph our original coordinates to start. Then I want you to do the rotation first, see what you get, and I'll have that written down. So you pause the video, do the rotation, unpause it, and then I'll have the rotation up. And then the second part of it will be the reflection, and I'll have you go and do that over the x-axis. So go ahead and pause the video and then go and do your 180 degree rotation to see if you get in the same spot as I do. Okay, so here is our rotation. So 180 degree rotation is pretty easy. You don't have to swap any coordinates. You just got to change the sign. In this case, also it's pretty lucky that we all started out with them positive and then we rotate it, or we change the sign. They're all going to be negative. So again, it should kind of make sense that we have 180 degree rotation. So I'm starting here. If I go 90, that would be over here in this quadrant. 180 over here like I have, and then 120 degrees would be right there. So hopefully that thought process of a rotation makes sense. That's going to be our first step in this, so hopefully this is what you got for that. So our second step is to reflect it over the x-axis. So just like that one that we did with over in part 1, we're going to take these coordinates here, and we're going to apply what we have right here in blue into our x-axis. And then whatever we get as a result is going to be our double prime. So we're going to reflect it over the x-axis. So hopefully we know our x-axis. This is where reflections can get a little tricky. I know I said with our if we have x equals, that's going to be a vertical line. But because that's talking about the x-axis, it is going to be what we know it to be. This could also be y equals 0. So if you saw y equals 0, that'd be the x-axis as well. So once you go and reflect this over here and get your new coordinate point. So again, pause and let's see if you get the same answers as I do. Okay, so here is our final step of this composition, which is going to be reflected over the x-axis, and that's what it should look like right there in green. And then, of course, here is our coordinates that represent that are double primes. Hopefully you kind of notice a pattern with this too. We're reflecting it over the x-axis. So if you notice our x's didn't change at all of those stayed the same, while our y's over here, all of those had the opposite sign or they changed signs. So just kind of something interesting to think about, and it should make sense. If reflecting it over the x-axis, your x isn't going to change, it's going to be the y that's going to end up changing with that. So right there is going to be our final number, or our final answer with those coordinates there. So this is the last transformation. Like I said, what we're going to look at, or what we looked at, was our translations, which was part 1, got that down, reflections, we got that down, and then rotations, got that down. So that's everything in this section. So hopefully that ends up making sense. So after you take your notes on this, there's going to be a little practice for you to do. So go and complete that practice and get a little bit better at this. So when it comes to the skills check and the test, you are ready and prepared for it.